Hi class, this is lesson 9.5, comparing functions. So today we're going to kind of continue wrapping up what we've learned about our three kinds of functions, linear, quadratic, and exponential. And so this little chart just kind of gives you a really good breakdown of what each equation looks like, what each graph looks like, and what each table looks like, and how you can tell which kind it is by looking at either the equation, graph, or table. So this is going to be something really good for you to study, not only for this test, but for your semester test as well. So take a few minutes to look over this chart, and then we'll try some problems here. Okay, so our problems today are going to be on comparing two graphs. And the biggest thing you want to look for is how they want you to compare them. So here we've got Sonia and Jackie. They each have, one has a table, one has a graph here, and they're selling cookies after school. They each charge a delivery fee. The revenue for the sales of various numbers of cookies is shown. And so we're going to compare the girls' prices by finding and interpreting the slopes and the y-intercepts. Because if you notice, like on Jackie's here, we can pretty clearly see that this is a linear equation. So we're going to start with Sonia first, just because her graph is first. And so we're going to find the slope of her data here. So if you'll remember from, probably seems like a way long time ago, slope, we subtract the y's on top, and then we subtract the x's on the bottom. So I'm just going to pick her first 2 points here, and so we're going to use each of those there to find the slope. So I'm going to subtract my y's, so on top I'm going to have 17 minus 11. On the bottom I'm going to have 48 minus 24. And if I simplify that, I should get 6 over 24, and that should simplify to 1/4. So there's Sonia's slope. And then her y-intercept, remember the y-intercept is where it crosses the y-axis. So that is going to be where x is equal to 0. So if x is equal to 0, now we got to find out what our y would be. So if we notice over here, we're increasing by 24 each time as we go up. Okay, linear functions, you're adding or subtracting the same amount each time. And the same thing is happening here. We're adding 6 each time. Okay. So to find out how much her revenue is, we just need to, since she's adding 6, we need to subtract 6. So 11 minus 6 would give us 5. So that means her y-intercept would be 5. So that would mean that if someone buys 0 cookies, they are still going to be paying $5, and that's what her delivery fee would be then. So now that we've done Sonia's, let's do Jackie's now. And we're going to find her slope and y-intercept as well. Now, Jackie's is a little bit easier to find the slope because we've got a couple different points that we can use here. So I'm going to just use these 2 points, and remember that slope is also rise over run. You can either use the formula or just use the graph here. So here I went from 2 to 8, so I rose 6. And then I went over 20. So if I simplify that, I should get 3 over 10. So there's Jackie's slope. And then her y-intercept is at 2. So there's my data I need to compare then. So in my sentence then, if I convert each of these slopes to decimals, I can a little better compare them. So I can see that Jackie is earning more because her slope is steeper. So she's earning more. She's her revenue's going up at a steeper pace. But Sonia's delivery fee is more. Jackie's is less. Okay? So on your worksheet, you would just want to write that out then to answer the questions on comparing them. Okay, let's try the next one here. Here we've got 2 guys that are depositing money into their checking accounts, and their account info is shown. And so again, we're going to compare them by finding and interpreting the slopes and y-intercepts. So I'm going to start with Dave first here. Let's find his slope. Okay, so I'm going to just pick 2 random points. I'll just pick the first 2. So I'm going to start by finding the difference of the y's. So 42 minus 30, and then 1 minus 0. Okay, so I'll have 12 over 1, which is the same as 12. So his slope is about 12. His y-intercept then, remember that's when x equals 0. Think of this as your x, this is your y. So when x is 0, y is 30. Oops. So there's my 12 for my slope, and then my y-intercept is going to be 30. So here, let's label that. So my slope of 12, y-intercept of 30. Alright, and so now let's go over to Arturo, and we'll find his slope. So it looks like, if I'm counting correctly, we'll just pick 2 points here. So I've got a 24, and this point is at 132. So it looks like he rose 8, and then he went over 1. So his slope would be a slope of 8. And then his y-intercept, remember the intercept is where he where it crosses the y-axis. His y-intercept looks like it would be at about 24. Alright, so now we're ready to compare. So it looks like if we look at just their y-intercepts, Dave started with more in his account, and then if we look at the slopes, Dave is putting more into his account than Arturo is every week. So they're actually never going to have the same amount of money because Dave started ahead and he's putting more money in each week. So he's always going to stay ahead of Arturo then. So that would be something you would want to write in a sentence then as you do your worksheet, as you can answer the question of how to compare them and interpret them. Alright, then these next ones, we don't have quite a linear function this time. We've got more of an exponential or quadratic curve going on. And so the way they're going to phrase that then is they won't say find the slope, they'll say find the rate of change, just because we can't find the slope if it's not a straight line. So what they want us to do is compare the rate of change from year 0 to year 10. So if we look at investment A here, here's year 0, here's year 10. So I'm going to put a dot on each of those of where the graph is at each point. And so then I'm going to, finding my rate of change, I'm just going to find what about the slope would be between those 2 points. So here's my investment A. And I'm going to, first of all, I'll write down the 2 points that this is at. So this looks to be at about 0.9. And then this one looks to be at about 1065. So I'm going to just find the slope between those two. So I'm going to take 65 minus 9 over 10 minus 0. So I'm going to get 56 over 10. And if I divide that out, I get 5.6 for my rate of change on A. And then I'm going to do the same thing for B. Find the slope between, remember I'm only concerned about years 0 and 10. So I'm going to do the same thing there to find my slope. So I'm going to take 6650, subtract 9, and then divide that by 10 minus 0. And I should, when I subtract that, I think I get 5750 over 10. And then go ahead and divide that, and I should get 5.75 for my slope there. So the way to interpret that then is you can see that investment B is going up at a steeper rate than investment A was in years 0 through 10. So it was increasing quicker on B than it was in A for those 10 years. Okay, and then we're going to do the same kind of thing on this last one here. So here we are only concerned about years 10 to 25. So I'm going to circle those here, 10 through 25. So I'm going to find the average rate of change between those. So remember that's similar to slope. We just don't call it slope because it's not a straight line. That's what's happening. So for A, I'm going to write down my points I'm going to use, 10, 1791. And my other point is 25, 4292. And then I'm going to find my rate of change using my slope formula. So 4292 minus 1791 over 25 minus 10. And I'm going to punch that into my calculator here. So 4292 minus 1791 gives me 2501 over 25 minus 10 gives me 15. So I'm going to go ahead and divide that out. So 2501 divided by 15, my slope is approximately 1.67. So that would be my rate of change for years 10 through 25, and now I'm going to do the same thing for investment B. So again, I'm only interested in years 10 through 25, so here's my year 10. That would be about right here. And year 25 looks to be about right there. So I'm going to have to just do my best to estimate there. This looks to be at about 1016 for that first point. And then this one looks to be at about 2533. So as long as you're close, that'll be fine. So go ahead and find your rate of change then. So I'm going to take 33 minus 16, subtract my x, or subtract my y's, and then subtract my x's. So 33 minus 16. So 33 minus 16 should give me 17. 25 minus 10 gives me 15. If I take 17 divided by 15, that gives me about 1.13 for my rate of change there. So what you would say is happening then, comparing the rates of change, is that investment A was increasing at a higher rate than investment B was for those 15 years. Okay, and then that wraps up our lesson, I guess. So go ahead, refer back to your notes as you do this. Remember your difference between slope and rate of change. Slope is when you have a straight line. Rate of change is what we use when it's a curved line, so a quadratic or exponential function. However, you find them the exact same way as each other. So keep that in mind. Go ahead and get started on your worksheet then.